Today we are starting with the first video on recursion. So as we have discussed in the recursion primer video, we are going to solve a few basic questions related to recursion. In every video we are going to discuss 2 or 3 different questions related to recursion, maybe using arrays or using strings, and even we can do one question and different variations of that. So in that way we are going to slowly build upon the thought process of recursive strategy or recursive way of thinking, recursive way of dealing with problems. So as and when we solve a good number of questions, very basic to medium questions related to recursion involving a variety of data structures, is when we can start moving to complex concepts, like to start with binary search using recursion, or sorting algorithms using recursion, or maybe linked list questions related to recursion. So in that way, gradually we are going to build upon the concepts that we are going to learn. So today we are starting with a very basic question, that is how to find a factorial of a number using recursion. Okay, so first of all, what is a factorial? In plain and simple words, whenever we are asked to find a factorial of a number, let's say if the number is 6, what we essentially mean is factorial of 6 is denoted by this. So what we essentially mean is 1 into 2 into 3 and then all the way up to 6. 1 into 2 into 3 into 4 into 5 into 6. So in simple words, what it is simply a product of a number, but it is the product of a number starting from 1. Okay. If we were not using recursion, let's keep aside recursion for a while. If we have to simply do this operation using iteration, using loops, so how we would have done this? If we used a for loop, we could have written a for loop, and we could have simply started from 1, I equal to 1, and then I less than n, I plus plus, and then what we would have done, we would have used this variable called maybe factorial, and then factorial equal to factorial into the number itself, and this n would have been this number like 6, so 1 into 2 into 3, and ultimately we could have returned this factorial variable. That's what we would have done in case of loops. So now let's see how do we convert this part into recursion. Okay, so if you look at this loop closely, as I had discussed in the primer video also, there is something called a base case. Base case is what? It is telling when the recursion has to stop. In case of loops also we have a base case, and that base case is nothing but we call it the condition, which is this, I less than n. So until it is lesser than n, my loop will work smoothly. The moment it is no more lesser than n, then it will come out of the loop and break the loop. Similarly, in recursion also we need to have something called a base case, where we are going to tell, okay, now this is a point where the function has to stop, the calling of the function has to stop, because once we reach the base case means we have already found the answer. Okay, so in this case, firstly we have to come to a base case. That is one thing. Second is the main core or the body of the problem. In the body of the problem, here we are just doing a simple product of the number starting from 1. In this case, when you are asked to find a factorial of a number, you are not given from where to start, you are just given a number. Okay, now it's up to you whether you want to start from 1 or you want to start from the number itself. It's all upon the implementation. Okay, so in the body of the problem is the actual meat of the question, where we have to do the actual computation to break the original problem into smaller subproblems. So as we were talking about product of the numbers, in which we are just trying to do a continuously, we are trying to multiply every number and we are incrementing the value of I. If I told you to do the same problem without starting it from 1 but starting it from the number itself, so how we would have done this? We would have changed this to n, and we would have changed the condition that I greater than equal to 1, and instead of plus plus we would have done minus minus, and the same thing we would have done. This fact might have been initialized to 1 earlier. Okay, so we are just going reverse. From 6 we are going to 5, and then from 5 we are going to 4, and then ultimately to 1. So this kind of thing we are going to implement in this case. Okay, so we will say if this n is reaching 1, if it is already 1, just return n. Okay. This is going to be the base case. And in the body, okay, before coming to the body, one more thing I want to say. When we are doing this I plus plus, in I plus plus, what is it trying to do? From 6 we are going to 5, and then from 5 we are going to 4. What is the pattern? We are subtracting from n, we are subtracting one number, means n minus 1 we are doing. On the n minus 1th number only we are trying to multiply the earlier fact, whatever the fact variable is holding, into I is what? I is nothing but initially it is n. In the next iteration of the loop it is n minus 1. Again in the next iteration it is n minus 1. So this is the concept that we are going to leverage, and we are going to say return this method only we are going to call, and then we are going to say return find factorial of n minus 1. Okay, but there is a catch over here. If we just call this function, where are we doing the multiplication? So we also have to multiply. So in the multiplication part we have to replace it with n. So initially it starts with 6, like in this case I was 6. So 6 into something which I'm not sure what it is now, but I know 6 into something is going to give me the rest of the product. So this, that we are leaving to this function, that it is going to return me something which ultimately when I will multiply with my n, I'm going to get the actual factorial. So when this function is going to be called n minus 1, then it comes in over here. Then it will check is n equal to 1, no it is not. Then again it will return n into this find factorial of n minus 1. So now let's try to run this 720. In this way we can convert any problem which is written using iteration using loops into recursion by breaking that down and then separating that out and put it in or plug it in required places wherever we require. The base case we got it from this condition. This n minus 1's logic we got it from I minus minus. And this fact into I we got it from here, and then we used it over here. So there are three parts, there were three hidden parts inside this loop which we utilized to form our recursive function.